Okay, so let's take a look at margin of error calculations. Our example says that a polling company conducts an annual poll of adults about political opinions. The survey asked a random sample of 505 adults whether they think things in the country are going in the right direction or in the wrong direction. 61% said that things were going in the wrong direction. Right, so what we're going to do here is just calculate the margin of error for the proportion of all adults who think things are going in the wrong direction for 95% confidence. All right, so we're going to use this formula, ME equals Z asterisk times SE of P hat. All right, so we're going to use this formula that I've just written to calculate the margin of error for the population proportion P, right? So for the population proportion P, that Z asterisk, that's the critical value for the desired confidence level, and SE of P hat, that's going to be the standard error of the sample proportion P hat. All right, so now you just need to recall from previously that the standard error of P hat is given by the formula SE P hat equals the square root of P hat times Q hat all over N, right, where Q is 1 minus P hat, right, and N is the sample size. So we first need to let P hat be the proportion of adults who said that things in the country are going in the wrong direction. So that value is 0.61. All right, if that's the case, then we can figure out Q. Q is 1 minus P hat. Q hat is 1 minus P hat. So that's going to be 1 minus 0.61, which is 0.39. Right, so then after that, we identify the value of N, which is the sample size. So N is given to be 505 adults. Okay. So I've switched to my StatCrunch, and I'm going to use the technology to find the critical value, which is the Z asterisk in our formula, for a 95% confidence interval. So I'll go to Stat, Calculators, and then down to Normal. Click that, and this is what appears. So I'm calculating for a 95% confidence interval, right? So for a 95% confidence interval, the remaining is 0.05. But in thinking about that, the calculators, or this calculator, only does a left-tail test or right-tail test calculation for us. But we would like to do the two-tail test. So that 0.05, our alpha, that's our alpha value. We cut that in half, right? So that becomes 0.025. 0.025. So I enter 0.025 because I'm cutting that in half, and I know for that standard normal curve, it's symmetrical. So one side will be 0.025, the other side will be 0.025. And then we can click compute, and I get negative 1.95, which is negative 1.96. And if you do it for the other way, let's see, 0.025, you get the same thing, right? 1.95, or we'll just call it 1.96. Okay, so in using the StatCrunch technology or some other technology that you're comfortable with, then we found the Z asterisk, which is the critical value, to be 1.96, right? And this was for a 95% confidence interval, 95%. What I'll do, I'll write down all the different values So for 90%, and this is usually what happens in a classroom, most teachers or instructors will write down the confidence levels and give you the corresponding values for the Z asterisk values. So that would be 1.645. These are the most common ones, right? 90, 95, and 99%. So for 95%, we just stated that it was 1.96, and 99% is 2.575, right? So these are the most common ones. If you needed to find others between those values, then you would go ahead and use the technology of your choice. So now that we have that value, we'll go ahead and start plugging into our formula. So the formula for margin of error is that what was mentioned above, that Z asterisk times our standard error of the p hat. Okay, so that gives us Z asterisk being 1.96. And then this is times the standard error. Standard error had its own formula that was given above as well. So that's 0.61 times 0.39. And that was all divided by that n value, which we stated was 505. And we take the square root of all of that. So once we do that, we get 0.043. So thus, the margin of error is about 0.043, or we could say the margin of error is about 4.3%. Right? So in a confidence interval, the extent of the interval on either side of the observed statistic value is called the margin of error. So a small margin of error corresponds to a confidence interval that pins down the parameter precisely. But a large margin of error corresponds to a confidence interval that gives relatively little information about that estimated parameter. Alright, so in this example, it states that it's believed that as many as 26% of adults over 50 never graduated from high school. We wish to see if this percentage is the same among the 25 to 30 age group. So first question, how many of this younger age group must we survey in order to estimate the proportion of non-grads to within 6% with a 90% confidence? Alright, so let's take a look at that. So here it looks like we're solving for n. So we're looking to see what n is. Alright, so to find n, we need a value for p hat. So within your problem, if there's not a value, preliminary value or reasonable guess for p hat, right, then we just use what's called the worst case value. So the worst case value for p hat is the one that finds the largest required sample size for n. So the worst case value for p hat would be 0.5. All right, so remember that for future problems if this situation occurs. However, in this case, we use the prior estimate of p hat, which is given as 0.26. All right, so this is found for adults over 50, and that's the best guess for p hat for us. All right, so then we use our formula, ME Z asterisk times the square root of p hat times q hat, all divided by n. Right, so this is going to be used to help us find that required sample size. All right, so then we would calculate the margin of error to find the Z asterisk value. Right, so for any confidence level, the corresponding critical value we can find using the technology as we did earlier using StatCrunch. or if it's the 90, 95, or 99, use that quick little table that I wrote down and reference that for your problems. Okay, so we're looking at a 90% confidence interval. So the corresponding critical value, Z asterisk, is 1.645. All right, so now we can go ahead and solve the formula right here, solving for n using our algebra skills. Solve for n, go through that. I won't go through that right now, but if you go through the algebra, you should come up with Z asterisk, right, to the second times p hat times q hat all over me, and this is squared. Alright, so now all we need to do is just crunch some numbers a bit to solve for that n. So we get 1.645, we square that, and this is multiplied times the product of 0.26 and 0.74, and it's all divided by 0.06, and let's not forget to square that. Alright, crunching those numbers, we get a value of approximately 145. Right? So that's the answer for part A. Now moving on to part B. If you rewind back, you'll see the questions. But part B's question was, let's suppose we want to cut the margin of error to 5%. Cut it to 5%, that margin of error. So what is the necessary sample size here? So to decrease that margin of error to 5%, then what we need to do is go ahead and make that quick change to the formula. So all that needs to be done is we plug in the values, 1.645 squared, 0.26, 0.74, and then we just create that change of 0.05 squared, right? That's all we do. And then crunch the numbers, we get approximately 209. Right, and then moving to the last question, part C of the question, said what sample size, right? So what sample size would produce a margin of error of 3%? What sample size would produce a margin of error of 3%? So if you notice that the new margin of error of 3% is half of that original margin of error of 6%, right? So let's take a look at this. So if you remember that the standard error was the SE of P equals the square root of P hat times Q hat divided by N, it declines only with the square root of the sample size. So to cut the standard error, and thus the margin of error, in half, you quadruple the sample size. So you quadruple the original sample size, 145, to find the required sample size to produce a margin of error of 3%. So there we have N is equal to 4 times 145, and then we get a value of 580.